Okay, this is a tough question. So we're looking at finding both Kc and Kp for this reaction. We do have our concentrations at equilibrium, which is good, but we're given moles and liters. So we have to have molarity. So concentration, those brackets we see in concentration are molarity. So we're gonna have to divide all of these by the liters. We also need to figure out what is included in our equilibrium expression. So I can see there's a solid here. So we will not include that. So our Kc should be equal to products. So H2 to the 4th power over reactants, CH4, no power, or power of 1, I guess, H2S squared. Because this becomes a squared, this becomes power to the 4th. So don't forget those. Now we got to find molarity. So I'm going to start with CH4, 1.2 moles over 5 liters. So I get 0.24. Then I have H2S equals 2.8 moles over 5, 0.56. And then I have H2, or no, CS2, which I don't need because it's not included. And then H2 is 0.042 moles over 5 liters. So 0.0084. These are all molarity. First thing I'm going to do is H2 on the top, so 0.0084. And that is going to be to the 4th. So I'm looking at this one. And then I have 0.24 on the bottom. And also 0.56 squared. This one. So we can move those up. Put that on the bottom, 0.56 squared. Now, if I put that in my calculator, I got 0.0084 raised to the 4th power. I'm going to divide it by parentheses 0.24 times 0.56 squared. And I get 6.62 times 10 to the minus 8. Find that, 6.6. There's the first answer. Okay, there's a part 2. So if I hit this next button, what is the Kp? Now remember, Kp equals Kc times RT to the delta N. Here we have, so delta N is how many moles of gases. So we got 4, and then we have 2 plus 1. So delta N equals 4 minus 3, products minus reactants, 1. So this is to the 1st power. Now R is our gas constant, temperature, 93 plus 273, 366 Kelvin. So we say Kc, which was 6.6 times 10 to the minus 8 times 0.0821 times 366 to the 1st power. I get 1.98 times 10 to the minus 6, which would be 2.0 times 10 to the minus 6. Okay, so 2 parts. Putting our equilibrium expression together with the right numbers in there, which you have to divide moles by liters, putting our answer, and then answering our conversion to Kp.